In the last video, we have created and actually finished input reader class that reads the tilemap into a generic I-value grid. Now, we need to map those custom values as integers for easier processing. For that, we will need an additional class called value manager. This will be a generic class that takes in the same type as we have gave to the I-value instance. So a tile-based type. We will be using value manager to access the values when we create an output tile creator. We will be using the value manager to create our output tilemap. Okay, so back to Unity. Let's create our values manager class. It will be in the input folder. Let's open it in Microsoft Visual Studio. Okay, let's delete mono behavior and put it in the namespace wave function collapse. Okay, let's create a jagged array of ints to store our mapped values. We call it grid. Next, we need a dictionary that will keep the mapping. For every value, it will assign an unique integer value. And we will call it a value index dictionary. And we need index integer value. We will be using index to assign new key values for our value index dictionary. Let's change the letter for small v. Okay, and we need to create this generic value of t, and that's why we need to make the value manager also a generic class. Now it all works. So basically the grid will represent our tile map as integer values that are assigned to I-value classes, I-value objects, and dictionary will store the mapping so we can retrieve the value from our index. Now we need to create a constructor and some helper methods that will allow other classes to access grid and the dictionary. The constructor will take a jagged array of I-value types, and we will call a method create grid of indices. Let's create a placeholder for it. Okay, and let's create this method. We will first assign grid to a new jagged array. We will call my collections. From the helper namespace, and we'll call create array. Type will be integer, and we'll take a grid of values length for both rows and columns. Okay, next we need to loop through the grid of values and assign indices to each unique value. Okay, we have our for loop to iterate over the jagged array, and we will call the method set index to grid position. And this will take the grid of values and the position that we are checking. And let's create a placeholder for this method, Alt Enter. In set index to grid position, we will check dictionary that we have implemented above if it contains the same value as our I-value instance. This is possible because we have implemented the I-equitable interface to our I-value interface, and every class that derives from I-value will have to implement this interface. If our dictionary contains the same value, we assign the index that already exists to our grid. Otherwise, we create a new index and assign it to our grid and to our I-value instance. So first we will create an if-else check. If value index dictionary contains value, if so, we will get the value and assign it to the grid. We will use link library to get the first value for our I-value instance. We'll call first or default, and we need to Alt Enter, and using system.link namespace. So basically what happens here is we search for a first value in value index dictionary that is equal to our instance of I value inside our grid of values, and when we find its key, we then can assign it to our grid. So we have retrieved a key value pair from our dictionary and assigned key.key to our grid. Otherwise, we'll create a new index. We'll make it equal index, and we will increase the index afterwards. We need to also add this index to our dictionary. And we call index plus plus. So this method will create the indices and so map our I values to unique indices and fill in the grid of indices, and we will check if it works correctly by checking this grid. So now we need just some helper methods for accessing the grid from other classes. So let's create them. First is get grid value. It will return an integer value and take the coordinates. You can see that I'm using X and Y, but you must remember that we are also considering rows and columns. So use the parameters that you feel most comfortable with. First, we will check if the parameters are inside the grid. We'll throw an exception. Index out of range exception. Grid doesn't contain X and Y value. Okay. Otherwise, we'll return grid value. And we'll need to call Y and X. So the other way around. Next method will get value from index, and that is what it will be called. It will return I value of t and get int index as an input. It will get the index from dictionary, and if dictionary doesn't contain this index, throw an exception. Otherwise, we will throw an exception. No index in our dictionary. Next method will be pretty lengthy, and it will be called get grid value including offset. So let's create it. It will return integer and take X and Y coordinates. So the main reason behind this method is that when we want to access a tile outside of our grid, so minus or bigger than the size of our grid, we will return the appropriate value that would be returned if we have created an offset. So the grid with multiple repetitions of our grid, and we will use a smart or an if-else check to return the correct values. So let's just create this method. First, we need to find y max and x max. Remember that y is now the rows and x is now columns. And we'll create a series of if statements to check what values should we return. First, it will be if the values are both less than 0. We will reuse our previously created method to get grid values. And we will use, maybe I need to change the sign here. And we will use a simple math. So if we want to access a value that is less than max, then we will take the max value and add to it the x and y. Since x and y are both negative values, if we access the value of maximum value, so for -1, we will return the grid length -1, so the last column and last row. And for bigger values, we will go further inside our grid. I suggest you just take a piece of paper and check it out for yourself, or just copy the values I have here. Let's implement the rest of the checks. It is important that we are comparing for bigger or equal to y max and x max, not just bigger. In case we have one of the coordinates greater than maximum value, we deduce from it the y max value or x max value, and this time we are approaching from the 0, point, and we just get the field that are towards the middle. So for the y equal to maximum value, we will get the value 0. And for the y bigger than max value, we will get the 0 plus the difference between the y and y max. Because we are checking through if statements, we can now just check for one coordinate, since we have checked beforehand for other instances where x might be bigger or smaller. And at the end, we just simply return whatever we have gotten in. It shouldn't happen, but because getGridValue throws an exception if the values are outside our grid range, it will automatically handle throwing the exception. Okay, so now we have implemented this method. Let's go to the last method. Sometimes we will need to get a grid of patterns values. So when patterns have a size bigger than 1, it will store multiple values. So sometimes for the patterns of size greater than 1, we will need to retrieve a jagged array of values instead of one value. So let's create the method that will handle it. It will be called getPatternValuesFromGridAdd. It will return a jagged array of integers and take x, y, and pattern size. Okay, and we will just create a new int jagged array of a size pattern size. We will loop through this new array and retrieve the correct values. We create array to return, call my collection extensions to create the jagged array, and it will take pattern size as size. I have misspelled the pattern size, so let's use Ctrl+RR. Okay, now that's better. So let's loop through this array. And let's get the correct values. So array to return. I will call our previously implemented getGrid, including offset. And we add x plus column and y plus row. So we will also need to return the array. So here we assume that x and y are bottom left corner of our pattern, and from there we get the pattern to the right and up. So the array will be taken like this. We will add to the past parameters the column and row and get the number of pattern that the pattern size is. Okay, if we have implemented everything correctly, we now should be able to test this class by accessing values and even with offset. So let's go to our test mono behavior and check if our values are correct. First, let's comment out this code and let's instantiate our value manager of type tile base, and this will call it value manager equals new value manager, and it will take our grid. Okay, we will use a string builder class to create a nicer looking grid of values to represent it more naturally. We need to call using system.text. Okay. And let's loop through our grid. We also need a list of strings. Which will store our rows. Okay, we need to create a builder equals new string builder. Okay, so we need to add to string builder what we have found. So builder append, and we'll append value manager get grid value including offset, and we pass column, remembering that column is axis on axis and rows are on y-axis, and we need to add a space between the values that we retrieve, and at the end of going through a row we will add to the list. So we call list.add builder to string. Okay, now we have everything inside our list. So let's call list.reverse. So we will print from the row 0, 0 upwards, so in the human readable form. And let's call for each var item in list. We will call debug.log item. Okay, so let's go to Unity and let's test. And we've got an error because we have not implemented all the conditions in our value manager. So let's go back to our value manager class. Okay, so let's go here. We are missing one statement. So if x is more than or equal to x max, or y is more or equal to y max, we need to return get grid value x minus x max, y minus y max. And also we have another error here. As I have stated previously, it's very important that we are comparing to equal, more than equal. Let's save it and let's go back to editor. Okay, and let's test it again. So now we can see that we have a values printed to us, and we are starting from the offset row below. Here we have our value in the middle. 0, 1, 0 would be equal to this road, and this road. 3, 4, 3 is line of trees, grass and trees, and also trees, grass and trees. And we can compare the outline. So on this side we will take this tile, so 3, on this side 3, exactly the same here. Up from this we get 0 because it's diagonal. Here we should have 2, and it is 2. And above we have 0, 1, 2, so the same as here. And below we have 3, 4, 3, the same as here. So it seems like everything is working great. In the next video, we will create our pattern manager class that takes care of finding patterns.